The next example is forecasting soybean prices, and we're going to take a hybrid approach that we talked about in the previous video. And that is, we combine expert opinion with empirical analysis to come up with a forecast. So here we have and the expert opinion that we're going to bring in is about a future event that we have to try to predict. So forecast for soybean prices given possible intervening trade war with China. So that's the event that we are trying to predict. So what happens if such an event occurs, and how do we adjust our forecast? So we have data going from uh, December 1988 to June 2018. Actually, we have up to December 2018. But what we're going to do is we're going to use up to June 1st, 2018 for modeling, and then we will use the last 6 months to compare with what forecast we are developing to see how good a fit that we are able to develop with the actual values. Okay, so this is kind of the training set, and this is your validation or testing set. We have the actuals and forecast for us to compare. All right, so the procedure that we're going to follow is we're going to fit with the available data a time series model, and we'll call that baseline forecast. Okay, so that's our step one. And then we're going to adjust that baseline forecast, okay, based on what happens or what is expected to happen if a trade war, if there is an intervening trade war, right? So we consider two different aspects. Okay, so when these are soybean prices, so if there is an intervening trade war, the demand for the US products is going to go down. And if the demand goes down, what will happen to the price? So we are actually forecasting the price. So it's a two-step process to adjust the baseline forecast to a forecast in case of a trade war. Okay, so that would be first simulate what will be the demand interruption. So how, and here we are going to look at the percentage by which the demand will fall. So if there is a trade war, then let's assume that we approached the experts and discussed with the experts, and we have come up with three different estimates as we have done in the past, the pessimistic most likely and the optimistic. So the pessimistic view is that it will go down by 18%, and the optimistic is that it will go down by 14%, but it's most likely than 16%. Okay. Now this is for demand, but what we want is an estimate of price change, so we can take the baseline price and adjust. So we need to come up with demand elasticity of price. So with this change in demand, how much of a price change can we expect? So that's the model. So demand elasticity, we're going to assume that there is an average elasticity of minus 0.9 with a standard deviation of 0.18. So that's what we have. So we're going to assume that the elasticity follows normal distribution. So we're going to use normal distribution for elasticity and a PERT distribution for the demand change. And we'll combine those two to come up with a percentage change. So here we have risk PERT So minimum, most likely, and maximum. So that's going to give us our estimated decline in demand in case of a trade war. And then we have elasticity, which is risk normal, okay, mean, comma, standard deviation. Okay. Now the price change is the percentage change in demand divided by the price elasticity. So the price change will be given by the demand change divided by the elasticity. So this is the percentage by which the price will go down if the the demand goes down by that percentage. So let's make that into a percent. Okay. So now we are ready to simulate we have to fit the baseline simulation, and we'll use this percentage change to get the forecast, adjusted forecast, and then we will do some computations with that.